Once you click Finish, the wizard will go and build the setup files required to run your case: the AGF, the WAN file, and the Leo file. If we go over to the console window, you can see the messages that are generated from the build process. The first thing that the build process will do is it will check the section data to see if the number of points matches what we inputted. Since it does, everything is confirmed and it can move on to the next step, which is to generate the WAN file, and then following that is the Leo file. If everything is okay, you'll see completed, and we can move on to the next step. Let's go back over to the Project Explorer, and you can see now under Turbine there is a row 1 directory with several files that have been generated underneath that. There is a .agf file, a .leo file, a .wan file, and 2 run scripts, runleo.bat and runwan.bat. If you are running Linux, the runleo.bat command is actually runleo.sh, and the runwan.bat is runwan.sh. So let's go ahead and generate the mesh by clicking on the Generate Mesh (WAN) link underneath Execute Case. A command prompt or terminal should open up, followed by several status messages telling you whether or not the generation was successful. If everything was, the command prompt should close. And let's now refresh the workspace by clicking on the button underneath Execute Case. What you should see now are several new files. The most important one is the row 1 file, which is actually the restart file, which is the initial mesh generated by WAND. So let's go ahead and execute the flow solver now by clicking on the Run Leo Solver link underneath Execute Case. You should see another command prompt open up, followed by several status messages and initial flow conditions. Now that that has completed, let's go ahead and refresh the workspace again. You can see that several new files have been created that include convergence files and performance files. You also have the ability to modify an existing case and change any of the parameters inside of it. Let's say, for example, we want to change the molecular weight from 28 to 35. So let's do that. Let's click Finish, and a new AGF file will be generated. You notice that by modifying the case and changing a parameter, the AGF file, the WAND, and Leo file are regenerated for that case. However, there are times when you may want to use the same settings for an existing case on a new simulation without modifying the original simulation. For example, design is very iterative. So if you wanted to use the same settings from a single simulation and change, say, one parameter, for example, the exit back pressure, in the case you were doing a speed line, you would have the ability to, in fact, create a copy of an existing case and modify only the data information that you want to modify. We call this the Create from Existing feature. So let's do that now. Let me show you how it's done. So go to File and start a new 3D single row steady case wizard. Let's create a new case name, something descriptive. Let's call it row 1 speed line 1 and put it under the turbine project. By clicking on Use Settings from an existing case and selecting row 1, this will import all the settings from our row 1 case into this new case. Now that that's done, let's click Next until we get to the exit back pressure. And let's change that to 50. And click Finish. What you should see now is a new Project Explorer, a new directory under the Project Explorer called Row 1 Speedline 1 with new files. So if you want to create many new simulations from existing simulations, you can use this feature to keep things manageable for yourself. In this way, the ADS Workbench can be a very powerful tool in helping you in your design process.